Hello, my name is Jacqueline Dean, and this is my 2212 Lab 3 bar magnet experiment. Okay, so the purpose of this lab is to use magnetic field models to better understand the relationship between distance and magnetic fields. We're going to use the magnometer map. I hope I'm saying that right. And we're going to develop physics model of the concept displayed above and visualize the magnetic field of a bar magnet. Some important initial physics concepts include the laws listed below, which we gathered from the physics notes. And from these, we can plug in different coordinates, or not different coordinates, we can plug in different variables that we have gotten from our lab data. And my lab data says that mu is equal to 3.26 am squared, and then n is equal to 2.5 based off of these results. To create our model, first we want the location of the magnometer on the phone pinpointed by sliding the phone perpendicularly to the ruler, both vertically and then horizontally, with the bar magnet on one end of the ruler in order to see at what position of the phone relative to the magnet the strongest magnetic field was being read. Some other notes about this model: some discrepancies may occur due to how the phone is positioned in comparison with the other magnets around and the Earth. We're also compensating for magnetic north by rotating the phone to follow the natural magnetic field of Earth. We also want to keep the phone away from any things that could potentially skew the data in the room that we are experimenting in. I know this is rather blurry, but this is the code that I used for my model on GlowScript, and then we can also see half of the data that I put into the Excel sheet that was given for this lab. Here we can see the rest of the Excel sheets, the graph, and the resulting GlowScript model from the code on the previous slide. Different causes for discrepancy within this experiment could be human error, which is just we have the wrong code, we have the wrong initial data taken. We could have inaccuracies in the magnet initial readings. And then finally, we could have the Earth magnetism and poles not lining up, as obviously the Earth has a natural magnetism itself, and we don't want to conflict with that natural magnetism in the poles. Some what if and explanation questions we also have to ask for this lab. What if you hadn't orientated your experiment to compensate for magnetic north, and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The answer is that the data in the end would be skewed because more forces would have been acting on the phone and the magnometer. This magnetic field from the Earth would affect the results in our final data. Our final what if question: if you were to stick two identical magnets together end to end and run the experiment again, how would you expect your measurements to differ? The results of this experiment would double, as there's now double the magnetic field. The results would also stay the same, or they would stay the same direction as the initial experiment. The process would be the exact same, but the data would change in the end. Thank you so much for watching.